which is negative 4a, and that's got to be 4, so a should be negative 1. So there are different ways of arriving at that. Some people did it differently. Number 4 was find all the zeros of that cubic. And so if you remembered the formula for factoring a cubic, that was okay, but you can also write this formula for a difference of cubes. And then you got to find the zeros of that quadratic, right? And I guess I'm missing a parenthesis here. Sorry, there should be a parenthesis here. Right? I completed the square for x squared plus 2x plus 4. And so that should be, yeah, imagine there's a parenthesis matching this one here, right? And that, yeah. Okay, so then the other zeros are 1, and some people just use the quadratic formula again. So you can either complete the square and use the formula. So then you got a rational function, and the two numbers not in the domain are negative 3/4 and positive 3/2, right? So you got to exclude those when you write it in an interval notation. That gives you the union of 3 intervals. Then the intercepts you get by saying, well, if the numerator is 0, then x must be negative 2. That's the x-intercept. The input is 0, then there should be a comma here, right? 0, comma, negative 2/3. Yeah, I don't see my typos until I actually read it out loud, and then they all come out. So this should be an ordered pair, 0, negative 2/3, right? I can go back and fix that. So anyways, those are the, so if the input is 0, the output is negative 2/3. You can see that most easily here, right? 6 over negative 9 is negative 6/9, which reduces to negative 2/3. And what are the equations of the asymptotes? Well, those are just the numbers excluded from the domain, right? So x equals negative 3/4 and x equals positive 3/2. The horizontal asymptote, well, the rule is, some people said no asymptote, and 0 is different than no, right? So no horizontal asymptote means there's a slant asymptote or worse. But if the degree of the numerator is less than the degree of the denominator, as is the case here, the rule is, or it just leads to the end behavior is approaching 0, both to the right and to the left, right? And so the graph, well, I accepted all sorts of approximations to this, but it should capture the fact that you've got the two intercepts, one at negative 2, and one, the x-intercept at negative 2, and the y-intercept at negative 2/3. You've got these two vertical asymptotes, one at 3/2, one at negative 3/4. And that it doesn't cross the axis anywhere else. So some people had it, going up here, in which case, you're going to pick up a couple intercepts which are none there. So that's a good reason for not having it go up. It's got to go down. And then over here, yeah, it crosses the axis, but then it rises up from below, right? And so it is asymptotic to y equals 0. And I just plotted a couple other points just to sort of a reality check that you can plug in, make a table of values to get a few anchor points. Number 6 then was this polynomial inequality. And the idea here was to make it easy for you, because I'm comparing a product equal to 0, right? So for you people who expanded that product, why? I mean, correctly do it is something you know how to do, is to multiply, but it doesn't help you at all, right? It only helps you if this is not 0, in which case you got to expand and combine, get 0 on one side, and then factor. But that's a lot of work. All that work has been done for you here. This is already in a nice simple form. And so you pick out the 3 zeros at negative 3, negative 2, and 1. But the 0 at negative 2, it doesn't change sign. It's equal to 0 there, and that's okay, right? Less than or equal to 0. So this factor has no effect on the whole thing. So it's only the other two factors, negative 3, zeros at negative 3 and 1. And so it turns out all numbers between negative 3 and 1, because say 0 is in there, right? And at 0, this is 3 times 4 times negative 1. That's going to be negative, so 0 is a solution, so all numbers between negative 3 and 1 are a solution. And that's that. So, so the next exam, so the chapter 4 test, I guess Tuesday, huh? So we will review on Thursday and test on Tuesday. So I will post some sample problems, but I mean the MyOpenMath is a good place to start. So we can bring that up and we'll take a break. Properties, logarithms. Start out with all right, so take 10 and we'll get back in.